you can simply tear down the infrastructure, which leads to pay-as-you-go. Another advantage of using the cloud is the pay-as-you-go pricing model, where you only pay for what you use. I like to compare this to using electricity at home. When you turn on the switch, you pay for it. When you turn it off, you stop paying for it. That is very similar to how the cloud works. This could be particularly useful when you are using IT resources for testing purposes, for example. And then finally, deploy globally. You can deploy your application globally in a matter of minutes. So what other advantages does the cloud offer? Here, we will discuss advantages of using cloud and compare this to your on-premise environment. So, firstly, trade upfront expense for variable expense. In an on-premises environment, you would need to purchase servers upfront, even before you can start using them. This requires you to have a big budget to purchase the physical infrastructure. Alternatively, when you're using the cloud, you don't need to invest upfront. Instead, you can use the resources and pay for only what was consumed. This takes away the large upfront financial burden. Second, benefit from massive economies of scale. Because AWS has thousands of customers using the cloud and is able to achieve high economies of scale, this translates into lower cost. And AWS is able to pass this on as a lower pricing for you. These costs will be much lower than what you could achieve on your own. Now, third advantage, stop guessing capacity. In an on-premises environment, you would need to make a decision upfront on how much resources you would need for the upcoming months. This involves a lot of guesswork, which may turn out to be inaccurate. You might over-provision, which leads to expensive resources that won't be used. Or you might under-provision, which means your applications might struggle with the low capacity that has been allocated. When using the cloud, you don't need to make these decisions upfront. You don't need to think about the long run, such as how much resources do I need in 3 or 6 months' time. You are able to provision the resources as and when you require by simply adding or removing them. Fourth advantage, increase speed and agility. Let's say your developer wants to develop a new application and take it to the market. In an on-premises environment, it could take weeks before you can provide the server to your developer to start working on the application. Because there are a lot of things that need to happen, such as purchasing the server, wait for it to arrive, setting it up, installing, patching the operating system, and then finally handing it over to your developer. In the cloud computing world, this can take place within a few clicks. Provisioning a server is just a matter of minutes. This makes it quicker to take your application to the market. And if the application didn't work out as expected, it is easy to fall back and just simply stop using the resource. Fifth advantage, stop spending money on running and maintaining data centers. Maintaining data centers includes a lot of administrative and maintenance tasks, like ensuring appropriate coding, racking, stacking, and powering the servers. We at AWS refer to this as the undifferentiated heavy lifting. What does that mean? Well, these are things that are common to any business and need to be done. However, they do not differentiate you from your competitors. Your product is what makes you stand out from your competitors. So instead of spending time and money on running these data centers, let AWS manage the physical infrastructure so that you can focus on more important things like your product and your customers. Last advantage, go global in minutes. Let's say you have customers on the other side of the world. Instead of creating a whole new data center in other parts of the world for your customers, the cloud allows you to deploy resources in multiple locations around the world. You can set this up in minutes. This means that you can provide a lower latency and a better experience for your customers. Even though we call it the AWS cloud, the services and the resources that we're going to be using are running in a data center on actual physical servers. And those data centers are positioned worldwide. Now, the basic building block of our global infrastructure is based on what we call a region. The region itself is not an actual physical thing, it is a collection of availability zones or AZs. A typical region will have 3 availability zones within the region. We'll call them availability zone 1 or AZ1, AZ2, and AZ3. Well, this availability zone, it is, for all intents and purposes, a data center. It might consist of multiple physical buildings, but they will operate as one logical data center. They are interconnected between them with our own AWS network, which consists of optical fiber, high bandwidth, low latency network. Each availability zone has redundant power, networking connection, so they are redundant on their own. However, by putting them together, connected with our network, we can attain what we call high availability. And to have that, we put the availability zones at a certain distance of each other, actually a maximum of 100 kilometers, so that if something impacts one of our availability zones, it will not potentially disrupt the other availability zones. If we then put our resources, like our compute, for example, in each one of those availability zones, we have ourselves an actual highly available workload. Now that we understand what a region is, how do we choose the right region? Generally, it comes down to 3 or 4 priorities. First priority is the data residency or compliance. If you have a regulatory or legal requirement that dictates where your data is kept, maybe it has to stay within the country it originated from, then you must choose the appropriate region. However, if this is not the case, then you have some flexibility to choose. Secondly, we want to locate a service as close to our customers who are going to use it as possible. This will help improve performance and give them a better experience. Third, comes down to service and feature availability. Not all services are available globally. So sometimes you must choose a region that actually contains the service that you want to use. And then lastly, cost. Different regions have different prices. Sometimes choosing a different region can help you reduce costs on your workload. Another important infrastructure element is the edge infrastructure. The various dots on the map display the edge locations that are spread around the world. These edge locations are used to serve cached content. Therefore, users are redirected to the edge location closest to them instead of going over multiple hops on the internet and retrieving data from the origin. This helps improve performance for your customers, increases security, and reduces cost. This is what we call a Content Delivery Network, or CDN. The service that provides a CDN at the edge location is called Amazon CloudFront. We also have additional services that operate at the edge, including AWS Outposts, Local Zones, and AWS Wavelength. Let's start with AWS Outposts. Outpost is a fully managed service that extends AWS infrastructure, AWS services, APIs or application programming interfaces, and tools to virtually any data center, co-location space, or on-premises facility, providing a consistent hybrid experience. Local zones is a relatively new type of AWS infrastructure deployment that places AWS compute, storage, databases, and other selected services closer to large cities, industries, or IT centers, where there is currently no AWS region. And finally, we're actually going to talk about this one a little bit later, AWS Wavelength, a new service that works with 5G technology. In this slide, we map on-premise resources to AWS services that can meet the same needs. Thinking about security, you might already be familiar with firewalls, access control lists, or maybe even have network or security administrators in your company. AWS has services that enable you to deploy similar security constructs. We have security groups and network access control lists, which we'll talk about in the networking module coming up. We've also got a service called Identity and Access Management, or the AWS IAM, which performs authentication and authorization to users for the different resources that we're going to talk about. From a networking perspective, you might be familiar with physical devices such as routers or switches, or basic network concepts such as IP addressing, traffic distribution, and flow. We have services such as the Elastic Load Balancer, which helps distribute traffic to multiple different targets or instances, or the Virtual Private Cloud, or VPC, which is your private network in the cloud, allowing you to control how your resources are connected to each other. From a servicer's perspective, you might be familiar with managing, deploying, or patching servers on premises, or maybe in a co-location. A key AWS service to meet this need is Elastic Compute Cloud, or EC2. We'll learn more about this in the next module, but essentially it allows you to deploy a virtual server that you can run your workloads or applications on. And then it's typical for a virtual server. You start with an image, which is what we call in AWS a Amazon Machine Image, or AMI. From a storage perspective, whether that's a network-attached storage or a persistent disk, maybe it's scratch space or caches, file systems to be shared between different hosts, or even a simple object storage for a wide variety of applications. AWS offers a number of different storage options depending on your requirements. Amazon Elastic Block Store, or EBS, offers easy-to-use, high-performance block storage at any scale. Amazon Elastic File System, or EFS, provides a scalable cloud-native NFS, or Network File System. And Amazon Simple Storage Service, or S3, provides object storage, built to store and retrieve any amount of data from anywhere on the web, which we'll talk about in the next module. AWS also has over 15 purpose-built databases, with RDS, or the Relational Database Service, being just one of them. So hopefully this helps you to apply your current knowledge to different AWS services that we will talk about later on. In the coming modules, we'll go a little bit deeper into some of these different AWS services. Now, let's have a look at how some of these services tie together with a very simple example. Let's say you have a web application which sits on a server that is accessed via the internet. The web application also needs to access some external data sources. As you can see from this architectural diagram, we have different services connected together to create the environment. In the middle, we have EC2, which, being a virtual server, hosts the actual web application. The application is stored onto an EBS volume, which provides block storage to the EC2 instance. The EC2 instance itself is deployed inside a VPC, which provides networking access. Now, as far as the data sources go, the EC2 instance could access data in S3, which is an object storage, or DynamoDB, which is a non-relational database. External users can access this web application via Route 53, which provides DNS resolution. Extending our architecture, we could use the data in DynamoDB as a source for a machine learning model we have designed using SageMaker, which could use Lambda functions, which are serverless compute, for the actual functionality. We will speak more about most of these services in the upcoming modules. Keep in mind, this is a simple example, but you can see how by connecting different services together, you can come up with a huge variety of different solutions, depending on what your requirements are. I like to think of individual AWS services as Lego blocks. And you put these Lego blocks together to build innovative solutions to meet customer business needs. Something important to consider is that we have different deployment models and ideas for different cloud maturity levels. What if you work for a corporate enterprise that was set up prior to the cloud? It is likely you are going to have a large physical infrastructure deployment that you've been using and probably had for many years. This is your on-premises environment. You're not going to want to just turn it off on Friday night, migrate everything into the cloud, and then on Monday just start operating in the cloud. On-premises environments can be slowly migrated, such that you operate in a hybrid model, where you have workloads and data in both your on-premise environment and your cloud environment. Now, alternatively, what if you work for a startup, a brand new company with an awesome, revolutionizing idea? Chances are you're not going to have the financial capital, nor the time, or even the desire to invest in an on-premises environment. So you might be thinking of a cloud-native design. Cloud-native refers to applications that have been designed and deployed only in the cloud. And then finally, think about the end of that migration story we talked about earlier, where you have migrated all of the workloads from your on-premise environment to the cloud. This is also referred to as all-in cloud. Now, in the end, it doesn't matter where you are in your journey. Once you start moving data into AWS Cloud, you can start making use of the services and the advantages that AWS Cloud provides. Now, let's summarize what we've learned so far. We have defined cloud computing as an on-demand delivery of compute, power, storage, applications, databases, analytics, intelligence, and other IT resources over the internet with a pay-as-you-go pricing model to provide faster innovation, economies of scale, and flexible resources. A key benefit of cloud computing is elasticity, the ability to automatically monitor and adjust compute resources to meet a fluctuating workload demand and continue to maintain the performance for applications hosted on the cloud. Now, in AWS, the service responsible for providing this elasticity is called auto-scaling. Auto-scaling ensures that a sufficient number of EC2 instances are available to run the application. We also talked about different deployment models available for customers with different cloud maturity levels. Public cloud is what we have discussed so far, where computing services are offered by a third-party cloud service provider, such as AWS, over the public internet for you to use and pay as you go. Private cloud is the opposite of cloud computing, where you keep your databases, software, and networking within your physical on-premises location. And finally, a hybrid model where customers have workloads and data in both their on-prem environments and cloud environments. Now, before we move on, some additional common cloud terminology. Infrastructure as a service, sometimes abbreviated as an IaaS, contains the basic building blocks for cloud IT and typically provides access to networking, compute, and storage. Infrastructure as a service provides you with the highest level of flexibility and management control over your IT resources and is most similar to existing IT resources that many IT departments and developers are familiar with today. Platform as a service, or PaaS, provides a complete development and deployment platform in the cloud. In this model, cloud vendors provide developers with the hardware and software environment required for building applications and services over the internet. This helps you to be more efficient, as you don't need to worry about purchasing resources, capacity planning, software maintenance, patching, or any of the other undifferentiated heavy lifting involved in running your application. Software as a service, or SaaS, is a model in which the vendor delivers a completed product that is run and managed by the service provider so that the applications need not to be purchased, installed, or run on the user's system. Software as a service users typically have to subscribe to the provider's software and access it using the vendor APIs or the web. Serverless computing is a fully managed platform that provides compute, storage, and network resources without the need for you to provision or manage underlying infrastructure. We'll talk more about serverless technologies in the upcoming modules. Big data, a tech term that has gained much momentum over, let's say, the last decade, which describes large volumes of data in a structured, semi-structured, and unstructured form that can be used for gaining valuable business insights using machine learning and advanced data analytics techniques. And of course, generative AI, or Gen AI. Generative AI is a very hot topic these days. It is a type of artificial intelligence that can create new content and ideas, including conversations, storage, images, etc. Generative AI is powered by machine learning models that are pre-trained on vast amounts of data. I hope you've enjoyed this session and found it interesting. We would love to hear what you thought about this session. Please take a minute to complete the survey. Your feedback is important to us and can really help us to shape and improve events and learn in the future. You can also reach out to us on the various social sites listed on the slide. And why not test your knowledge? Make sure you complete the knowledge check after this session to see how you're progressing. This brings us to the end of this module, but this is only the beginning. For our next module, we will introduce the foundational services of compute, storage, and databases on AWS. Thank you.